Hello, welcome back. This is Matt SB, and I'm going to be teaching you today about functions in R. We're going to go over what a function is in R, kind of the anatomy of a function, how to write a function, how to document a function, and then some basics on how to test a function. Again, I am in a development environment called Emacs. So it's functionally going to be the same as RStudio. You see I've got a script on the left, I've got my R console on the right. So it's going to behave almost exactly like Emacs, or like RStudio. So let's dive in. What is a function? Well, we've actually been interacting with a lot of functions in R in the previous lessons. So one of the functions we've seen is mean. So here if I type mean 1 through 10, hit enter, it gives me back 5.5. So what exactly is this? Well, mean is a function that calculates the mean of a set of values. And here I said take the mean of a series of values 1 through 10. Again, this is shorthand. There's a lot of code that goes into taking the mean of something, and we can reuse that code by just typing mean. What maybe is a little bit unfamiliar to people is the colon operator is actually a function itself. So here I'm going to use the backtick. It's located above the tab key on most keyboards. So backtick just says treat this literally. Don't try to evaluate this, but treat it literally. So here I say backtick colon backtick means the colon function, and if I do 1 and 10, it gives me that sequence, and it's functionally the same as this. So that is a function. Actually, the plus is a function as well. So what you will begin to learn is almost everything you're interacting with in R is a function, and that really has some powerful implications. Once you become a little bit more advanced, you can actually do stuff with this. But for now, know that a lot of these things are functions. They have a name, so we'll go into the anatomy of a function. They have a name, so when I type mean, the name of the function is mean, and then I do 1 through 10. That's actually an argument. So inside the parentheses to a function is an argument to that function. Here I don't name it, but I could say x equals 1 through 10. So the argument is named x, and we're giving it the value of 1 through 10. Enter. The return value of the mean function here is 5.5. So it is actually returning the calculated mean. We can have several arguments to the mean function. So another argument is na.rm. We've seen this in office hours. If I say true, that means remove all the na values. These arguments are in order. So if I basically, let's say I leave out na.rm equals true and I hit enter, it gives me an error. Well, why did it give me an error? It says trim must be numeric of length 1. Well, what did I do here? A little bit of detail, maybe a little confusing, but when I type mean, it's actually dispatching to mean dot default. We can talk about this later. It's a system in R called S3 methods, where a function with the same name can have multiple different methods associated with it. So you can have a method, the default method is just take the mean of these values. There might be a special method for a data frame. There might be a special method for a matrix, and so on. So here, if we want to look at the args of a function, we actually use use another function, the args function. So here we'll do mean.default, and we'll see the args for this function. We have x, trim, na.rm, and then dot dot dot. The dot dot dot, we don't call it an ellipsis or an ellipse. It is dot dot dot. Just a weird thing. That's what our programmers call it, is ... So this argument has 4 functions, and the order is x trim ina.rm equals false. So if we actually wanted to do this again, what we have to do, if we don't give it a name, we have to put it in the 3rd position. We leave that 2nd position as blank, and then if you hit enter, it'll go through. It's just really basic overview of functions in R. So why do we write functions? So we write functions primarily because we want to save on typing. So you can imagine, let's say we're doing A equals 10 plus 1, and B equals 10 plus 2, and C equals, okay, you get where this is going. Let's say we'll copy and paste and say, well, C equals that plus 3, and D equals that plus 4. So we're copying and pasting here, and we're repeating the same thing over and over, and we're really just changing the 2nd number that gets added to 10. So this is generally bad. This is tedious, and error prone. If I could type. So we want to avoid this. You can imagine, let's say I'm doing this 20 or 30 times, and I accidentally copy and paste incorrectly, and I get, 10 equals, or C equals 10 plus 2. This is hard to catch. You basically have to scan back through all of your lines of code and find this. And this is a kind of dumb example, but you can imagine where this crops up a lot is making plots, reading in files. So let's say you have to read in 20 different CSV files. You maybe will copy and paste it wrong, and you read in the same file twice, but you assign it to a different data set. Another thing where this happens is where you're taking summaries or somehow need to do some data cleaning, and you're copying and pasting a ton, and then you end up with an error, and it's really hard to catch. So what we want to do to avoid this is we write a function. So here we're going to write a really basic function. We're going to call add to 10. And this is how we write functions in R. I'm going to write this function, and then I'm going to go over what I'm doing. So that is it. That's the entire function. Well, what are the pieces here? Remember before I said every function has a name, so here's the name, add underscore to underscore 10. I'm assigning to that name a function. Again, the assignment operator, you can use this as well, the arrow. I use the equal sign for reasons. So here I'm saying assign to add to this name, add to 10, a function that has a single argument. That single argument is x, and the body, this part between the two curly braces, is the body, and the body is just 10 plus x. So we can run this. We can look at what add to 10 looks like. You can see that's exactly what we typed. And I can say add to 10 1, and it gives me 11. So this is our function. The return value is the last thing inside the body. So if I say, temp equals x to the second, and temp 2 equals 10 plus 10, I can type all kinds of stuff in here. The only thing that gets returned to me is the last value. Another important thing is only a single thing can be returned. So if I say, 10 plus x, and then, x raised power of 2. This won't work. R is going to give you an error because it says, well, this isn't a single thing. If I do this semicolon, which we've seen before, it's going to say, well, the last thing that is evaluated is x raised to the power of 2. So here, if we actually run this, repeat, add to 10 of 1, I get 1 back because the last thing that gets evaluated is actually this. The semicolon just is the same as putting it on a new line. So let's clean this up. So that's a really important thing is if you want to return 2 things out of a function, you basically have to concatenate them together into a vector, because then R says this is a single vector. I'm returning a single thing. The single thing is a vector, and you can say return the vector. So if we evaluate this and we rerun our add to 10, we get back a vector. So that's an important rule is R will only return a single thing. So if you want to return multiple things, you can concatenate, or you can turn them into a list, or you can create a data frame where each item that you're returning is a column in that data frame, but you need to basically fit multiple results into a single object for you to be able to return them. So here we'll set this back. Okay, so that's a really quick, brief overview into a function. We're going to actually write a more complicated function. This little toy one is not very interesting to write. So here we're gonna work with our COD dataset again, and here if we look at the head of this, we see we've got a bunch of different columns. One thing that you might be interested in when you look at this is we can look at a summary of COD. Summary by default, when you give it a data frame, is going to summarize each column. So here we can look and looks like we've got samples 1 through 1254. We've got intensity. This is interesting. We've got a really high value of intensity. It's much larger than the third quartile. When you scan through these again, depth looks fairly uniform across them. But here on weight, again, we've got a really high max value relative to the third quartile. And again, with length. So when we look just scanning through these values, we might say, we'd like to figure out if there's any outliers in these data. So how can we find which values are outliers? Well, a really simple outlier, a way to detect outliers is if the value is basically greater than 2 times the standard deviation from the mean. So what does this mean? Well, so that's mean, and really we want the absolute value of that because this is maybe a definition of what an outlier is, right? Is the value x difference from the mean, the absolute value of that, is it greater than 2 times the standard deviation? What did I just do here? This is actually the important first step of writing a function, is trying to figure out what you're trying to do. As my mentor likes to say, where we get in the most trouble is when we start typing code before we know what we're doing. And so first step, number 1 of writing a function, write down what you're doing. And this is actually really good because you can oftentimes, as you write down what you're trying to do, it'll clarify either you aren't clear what you're trying to do, it might not be obvious, or you might be confused, or 2, you might, as you're writing it out, clarify what you're trying to do. So here we just wrote down, all right, we want to find the outlier. This is kind of this is a definition of what an outlier is. But we might be more specific. So we might say we want to find the outliers. So what does that mean? We want to find the outliers. Do we want to find which index position they are? Or do we actually want to return the values? So let's say we'll return the index position. And then we want to calculate that by this, by this thing that we typed out before. So, and actually we got a little sloppy. It's greater than 2 times the standard deviation of x. So this is a nice little step 1. Document what we're doing. Write some basics of what are we trying to do. Alright, so step 2 of writing a function might not be intuitive to some of you. Write a test. So why do we write a test before we write the function? This is really going to be this is important because we need to know if our function's working correctly, but just like writing down what we're trying to do, this helps clarify our thinking. We can look at this test and say, yes, this is exactly what I was trying, or, oh, as I'm writing this test, it's not really clear what a successful function will be. So for our outlier, we'll say, what is a test? Well, if let's say we're going to call our potential function outlier, and if we give it c, let's say we repeat 1 10 times, and then we give it 100. So we're going to hand it a vector with 10 ones and then 100. We want it to return that 100, and we want to return the index position. So this should result in 11. So how do we write a test? Well, the most basic way in R is we use a function called stop if not. And what this does is it's going to evaluate whatever's inside the function, and if it's not true, if whatever's inside is not true, it's going to issue an error. So we'll copy this down and we'll say, so if we run our function outlier and it does not return 11, this will issue an error and say, hey, this isn't true. There are a lot of other testing functions, or there's whole packages written around testing. This is a really basic one. This is what we'll start with. As you get more and more into writing functions, you might want to look into these other testing procedures, but for now the basic one is actually really helpful for us. So what's the step 3? We're going to write the function. So here we already said we're going to call it outlier, and we're going to give it x as just a default argument, and we're going to go through our steps above. So we might need to calculate the standard deviation. We'll use the SD function. We might need to calculate the mean, so we'll use the mean function, and then our definition is if the absolute value of x minus the mean is greater than 2 times the standard deviation. So what will this return? This right here is a logical operator. So this will return a logical vector, and it'll tell us whether if x is 10 items long, it'll give us a logical vector of 10 items, and it'll tell us which ones this condition is true. This isn't bad, but it doesn't tell us the index. So we'll do this, which will return the actual index. So because this is the last value, inside the body of the function, it'll be what gets returned. And we can run this. We can make sure that it actually defined it. Looks good. And then let's run our test. And our test actually didn't do anything, which means this should be right. Outlier. So, step 4. Run test. So, that's a very, very basic way of writing a function. This is essentially how I write every single function, no matter how complicated or how simple. I do this. I basically have to write down what I'm doing. I write a test to basically evaluate whether the function that I'm about to write is correct or not. And then I run that test and see if it passes or not. If it passes, then am I good? Maybe. We'll talk about that in a bit. If it fails, then I know I need to keep adjusting my function until it passes. So why was I a little hesitant to say, well, it passed my test, I'm good? Well, it passed that one test. I might want to run a couple different other tests to see if this is actually doing the right thing in all situations. So what does that mean? Well, what if I do, here, we'll copy our test down. And this is 5, expand the tests. So what if instead of, I repeat 1 through 10, or I repeat 1 10 times, what if I drop this out? I drop out, so all we're feeding it is a single vector of 1s. What do I expect here? You might not know what to expect, so you could just run the function, but it's good to, before you run this, say, what do I expect? This is kind of hard. Well, you expect it to return nothing, right? So how do you test for that? I don't know. What do you think? You can say, is it equal to this, a string? This might actually work. This will coerce the result of this to an empty string. So we can try it, and voila, it worked. But now we actually want to look and see, what does this return? Because this was just a guess that it returned, that we could use the empty string to test for this. It actually returns an integer of length 0. So the better way to test this behavior is if we say the length of outlier equals 0. So this is just a way of thinking about, and this is super helpful, thinking about how you write tests, how you will test your function's behavior will tell you how to write a better function. And it also catches, before you start using your function, if it's, you deploy it, it seems like it's doing the right thing, it suddenly issues errors. This is how you basically develop software. So hopefully that's clear. I'm going to say one last thing. How do you document a function? So I'm going to just copy it for convenience. So here's our function, we just wrote it. The most basic documentation is just a comment that says what the function does, and then the other thing that we want to do is say, what is x? X is it's a numeric vector. This is the most simple way to document a function. It's just comments, it's along with the function, but you want to basically, if someone else or yourself in 6 months comes across this, you want to basically say what's going on. You can also document inside the function. You can say, return index. This is really, really basic. The other way to do it is a thing called roxygen. So in RStudio, there should be a hotkey. I don't know what it is, but oops, that was can do this, which basically puts in an roxygen block. This is a standardized way to document functions. What happens is this can be picked up by another piece of software and turned into an official help file, either HTML or like a PDF. So this is another way of documenting. You can read up on this. I'm not going to go into a lot of detail because we're already at the 25-minute mark, but I will go over this probably in a second video of how to use args and basically how to do a little bit more robust function writing. So that's all for today. I'm going to put in a block down here of some exercises that you can try on your own. And if you have any questions, reach out over email or office hours on Thursday or Wednesday, depending on where in the world you are. Anyway, hope this was helpful.